Hey everyone. Today we're going to be learning about the Turing machine, which is the essence of computation and it is a work of Alan Turing. Okay, starting off with our members, starting with me, I am Sriram Analaki Sundradas. My matrix number is 224149.
Hi, my name is Zakaria bin Ali. My matrix number is 224259.
Assalamualaikum and hi, my name is Muhammad Hakim Ashraf bin Ismail. My metric number is 223234.
Assalamualaikum and hi. My name is Muhammad Daniel Haziq bin Abdul Manah and my metric number is 225031.
All right, that's it for our members. And now, let us get into the introduction of the Turing machine. All right. The Turing machine consists of three parts. Firstly, it's a finite state control that issues commands. After that, it's an infinite tape for input and scratch space. And lastly, a tape head that can read and write a single tape cell. And we have to know that at each step, the Turing machine writes a symbol to the tape cell under the tape head and changes state as well as moves the tape head left or to the right. And this we will see much more in depth in the upcoming slides. And it says something over here. To think, how does a human compute? This is essentially how the motivation of it came about. First, we write an input on a paper. So you can see I have a pen and I have a clipboard. So we write an input on a paper, right? And from that, we do the computation. We process on how to solve an issue. And finally, we write the output on the paper. Like we can say basic maths, like 2 plus 2 is 4. That's the question. No, I mean, 2 plus 2 is the question. So we process what 2 plus 2 is. 2 add 2, it becomes 4. And we write down the output, which is 4. All right. Now, the motivation behind the Turing machine concept. How does the concept of human computation translate to Turing machine? Okay. As I said earlier, for when we see it as humans, we use a clipboard in which in the machine they use a tape. And for us, we use our pencil to write, which in the machine, they use a tape head. And our thinking process translates to the transition function of the machine. And with this, we can understand how the name of the Turing machine came about, which Turing stands for Turing from the name of the maker, Alan Matheson Turing. And the machine comes for it being a computing machine because we're computing a problem. Yes. Turing's aim. Why has he done this? It is to design a model that is simple, intuitive, generic, and formalizes computation performed by a human mind. All right. Next, continuing to Zakaria to explain the Turing machine model.
Okay, hi. Uh, I will be talking about the Turing machine model. So this is a model created by a YouTuber called Dave Buster. This model embodies a classic look and feel of the machine presented in the Turing's 1937 paper. So as you can see on the left-hand side picture itself, it's a machine that was made based on the Turing's 1937 paper. So what are its functions? Next slide. Right. So, in order to understand what I'm talking about, I will be um, explaining one by one. So first, we should look at where the tape is. So the tape is where um, the tape is basically like a paper where we would write on it as present our output. So as you can see, the white round thing on the right is the tape, and it will move from right to left. Okay. So the first function it has is it has the ability to write, read, and erase writings on the tape. So this machine can read, write, and erase the symbols it's written on the tape itself. And then next, the machine reads the symbol at the current tape position. I will be explaining this further in the next slide. And then based on the current state on and the symbol read, the machine consults its transition rules to determine to the next state symbol to right and whether to move the head right to the left. I'll explaining this also in the next slide. And then steps are repeated until the machines reach an accepting or rejecting state. So if the machine reaches an accepting states, it signals that the input is accepted. If it reaches a rejecting state, it indicates that the input is not being accepted. The machine halts its operation when it reaches an accepting or rejecting state. So basically, the machine will loop the write and read will loop. The write, read, and erase process will be looped until it reaches an accepting or rejecting state by the end of it. And then next, I will be talking about the compartments in this system, in this model. So first, it has a 1,000-foot long white tape, which you can see on the white thing on the right side. Yeah, on the right side. And then Next, it has an ESL 1401 line camera. This camera is capable of detecting the input that is written on the tape itself. And then after that is the marker. Marker is where the input is written. Let's say like the input is 001. So the 001 will be written using marker and it moves in y-axis only. It moves y-axis and x-axis using a motor that it's too small to see, but there is somewhere along there. And then next is the eraser. As you can see, the white round thing besides the marker is an eraser. Basically, it will rotate using pulley system to erase the let's say the number that was written on the tape. So that's the function of the eraser. And then next is the motorized roll stand. This is to like pull or push the tape so that we can write on the perfect position it wants. Let's say it wants to write on the third number. So the pulley system will pull or push until the marker lands at the third position. And then lastly, And then lastly is the control panel. Now this is the compartments that we can see from the outside. Next, I will be talking about the compartments from the inside. So by the way, the control panel is where it's like the brain of this model. Basically, we give every single command or like instructions that are needed to the control panel, and the model itself will be capable, and the model itself will do on its own. So next is the hidden compartments. So first we have the custom display board, which is beneath the control panel. So as you can see, there's like 3 red display on the up. That is basically what it tells. It tells on the left side how much it reads input, and then next is the position, and then lastly is how much it has erased. And then next is the second PC board. It contains a parallax propeller chip. This parallax propeller chip provides all control for the machine. And then after that is the third PC board. Third PC board locates right next to the second PC board. It provides the power and control to the servos and motors used in the machine. After that is the SD card inserter. So at the side of the control panel, SD card inserter are used to write and save programs in forms of like text files. So when we want to like insert a program in this machine, we need to type it out, write it in the text file, and then insert it into the control panel. And then lastly is the user console or the control panel. It uses 5 switches to load, define defaults, move or erase tapes, run in a single step through programs, and can create and edit program files. And then this is like the video on how the Turing machine works. Due to restrictive time, I think we won't be showing this, but if you like have a lot of free time, you can check it out yourself. Next, we'll be talking about halting problems, which will be presented by my other fellow groupmates. Thank you.
Okay, so guys, what is actually halt? Halt is actually to bring to a stop. So the meaning of the halting problem is a statement about computational processes that it's question whether a specific algorithm exists that can determine if any given computer program will halt or run indefinitely. So next, next. So basically, halting problem is the problem which can never get conclusion and it will loops forever in the program. So for the example, I will show you a diagram on how halting problem happens. So imagine if you got a machine, halting machine, and that has a program in it. So when you input something, uh, does the program halt on the input that you put? So if the program halt, it means yes. So it will infinite loop. It will loop infinitely until like tomorrow or never stop. But if it is not halt, it will halt. So it eventually will also be yes, and we will infinitely loop for the machine. So this is called halting problem. So for the another example, next, as you can see, for instance, for another example, if a program is starts to finding the largest prime number, it will theoretically run forever because the largest prime number you will never know because it will go much further until you have no place to put the number. So if another program can definitively state that it will indeed run forever, it will have solved the halting problem. So next. So why halting problem is significant in theoretical computation? The halting problem is crucial for understanding computational limitations. It sets the boundary for what computer can and cannot solve. It impacts fields including artificial intelligence and cybersecurity. So it turns out there is no possible machine that can solve the halting problem. It doesn't matter how good it is, the program, but it cannot solve the halting problem. So next, I will pass it to Haziq to explain about Turing machine and compatibility.
So next is the Turing machine and compatibility. Compatibility of Turing machine. What is compatibility of Turing machine? The concept of compatibility in the context of Turing machines refer to the ability of Turing machine to solve a particular problem and compute a specific function. A function is said to be computable if there exists a Turing machine that can compute it. Similarly, a decision problem is computable if there exists a Turing machine that can decide it, outputting yes or no for any given input. With enough rules, state, and tape, we could build anything, even if it is inefficient but theoretically possible. There is no computer more powerful than a Turing machine. A computer that is as powerful is called Turing complete. So what is Turing complete? Turing complete is a system or programming language that can simulate a Turing machine. For example, programming language such as C, Java, Python, and others. Every modern computer system, such as our laptop and mobile phone. Okay, next. But unfortunately, Turing concurred with Alonzo Church, who is his teacher, by showing that there exist mathematical problems which cannot be decided in a finite number of logical computations by Turing machine. Such unperformable operations are called non-computable functions, and their existence is consequence of the existence of uncountably infinite set, such as halting problem that we discussed earlier.
I would like to add one more thing. So I forgot to mention about the Turing machine model application in the real life. So in the real life, Turing machine model application is used in counting what's it called? Counting decibel numbers. And basically it's used in an ATM machine, and also it's used in algorithmic information theory and complexity studies, software testing, high performance computing, and machine learning. And that's it.